Hi there, my name is Rithvik, and welcome to my third vlog of my 3M YSC journey. I'd like to reintroduce my project, Tecton Forecast AI, a machine learning model that I built, which can predict earthquakes using adaptive techniques. This time, I'd like to elaborate more about my project, especially about the scientific method and how I'm using observations and problem identification to further streamline the process of the scientific method in my project. I'd first like to talk about the topic that I'm in, earthquakes. Earthquakes have been shown to kill 10,000 people in the US every single year, according to National Geographic. And tens of millions of dollars are wasted each year in infrastructural damage. So clearly, they're quite damaging around the world everywhere. And the bad part is that they're unpredictable, and we may never know when and where these earthquakes will happen. This calls or prompts for a new system, a new way to predict earthquakes before they happen. Another problem about earthquakes is that there are different dampener mechanisms and defensive mechanisms for these earthquakes, such as Taipei 101's dampener mechanism, which can center the base of the tower to counteract the movements of an earthquake, and base isolation systems in many US buildings near California to prevent the sliding of a building by making it very valuable at the base of the towers. Is that these different resources and architectural techniques are not known to many of the resource-poor regions around the world, and therefore calls for a predictive mechanism that can be employed around the world through online procedures to inform others of the likelihood of an earthquake that's about to happen. This is more efficient and can be applied widespread around the world. This is where there are multiple aspects to the problem of an earthquake. Earthquakes are multifaceted, and this calls for a more online solution. Now, another problem arises is the fact that these resource-poor regions won't have the stations that many of the third world countries have now, such as GPS stations, seismic stations, etc. So they may not have the resources to establish the stations and the experts to employ them in these stations. So I had the idea of developing an IoT device, which is cheap and can be integrated into any of the mechanisms around the world, even if there isn't any mechanism already employed, to be inserted into the ground, which can detect those GPS movements and seismic activity that a station can for around the cost of $100. This is significantly cheaper than establishing a high-tech station. This, pairing the software and hardware both together, allows me to have a very widespread accessible system to be used around the world, as both the AI model can be used online for people with access to the internet to check the likelihood of an earthquake in their region, as well as improving the accuracy of these readings by forwarding directly to the cloud model by employing these devices directly into those regions. This is the process of the problem identification, a gray area which is usually in many fields. But the topic of AI-based earthquake prediction is very significant, as we need to cut through the fog that is there in such fields where there are multiple different solutions tried without a stepping stone to build off of, due to the many widespread uses of AI in our world and the many novel techniques that we're finding out each and every day and testing them on earthquakes to see if they do any better than the rest. This is why my project utilizes novel architecture based on researchers' models to improve based on the advantages that others found and the weaknesses that others found in different models, and combining them into this conglomerate that can be used for adaptive use cases. Since usually the problem with earthquakes for stations and prediction is that you can't have one model that can dictate all predictions. For that, there are many different complex mathematics and relations between boundaries that you need to really calculate well. This is why if we had a region adaptive model in each and every area, we could therefore increase the likelihood of those predictions to be true, because they are fashioned exactly and tailored exactly for those plate boundaries and that specific region itself. Implementing the technique of process of elimination, I've been able to eliminate different potential solutions for these different problems to pick the most optimal configuration of components to have the most impact on widespread problems, as earthquakes is a very broad topic and can be dealt with in a new multitude of ways. So this setting clear goals and setting clear solution base has allowed me to find direction in my project and continue making progress in this journey. Based on the solution base I just described, I've been able to make significant progress in my journey by having my mentor meetings as a favorite part of this journey so far, by dealing and discussing these different obstacles that I'm facing. So far, the most challenging obstacle that I had to overcome is pre-processing my data. Data is a very continuous thing in our world, as data can come in numerous different forms about numerous different topics and requires some inside knowledge to really understand what's important in the data and what's not important. What did the loggers really mean about their certain different observations in the data? So, working with this allowed me to think like a true seismologist in the field to try and figure out, like a detective, what are the components of the data and how I can engineer them for optimal use in my case. I believe the thrill of innovating and finding new ways to work around such problems and using the process of elimination and ideation of different solutions has its own benefits and is one of the reasons why 3M scientists love to solve problems each day, as the thrill of problem solving is something that no other activity can truly give, as problem solving gives you the ability to use limited information to derive multiple different conclusions about a problem, just like a detective, and also engineer your own solutions based on other people's work, which allows you to learn, adapt, and devise your own solutions with creativity. This is why I believe 3M scientists love to solve real-world problems, and is why I am also continuing this journey in the 3M Young Scientist Challenge. Thank you for watching, and I can't wait to see you all in the next vlog. Goodbye.